Lesson 9.4 is about triangle congruence postulates and theorems. A postulate is a math statement that we accept to be true without proof. A theorem is a math statement that we accept to be true because it can be proven using postulates. I'm not going to have you prove any theorems. You can use all of these postulates and theorems to show that triangles are congruent in this class. And that's our goal. You're going to use the congruence postulates and theorems to determine whether triangles are congruent. So each of these postulates or theorems, they represent like the bare minimum information we need to say for sure that two triangles are congruent. One way is by knowing all the sides. We don't have to know any angles, but if we know all the sides of one triangle, and we know that they are the same length as all the sides of another triangle, that's enough to say the triangles have to be congruent. So let's fill in these blanks. If three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. They have to be. So you can see, we could write out a statement like this. If we want to show that the two triangles, BOW and MAN, are congruent, we can break it down and say, well, here's a pair of congruent sides, here's another pair of congruent sides, and here's a third pair of congruent sides. All the sides are the same length, so by the side-side postulate, the two triangles have to be congruent. We don't actually need all the sides, though. We could have two sides and the angle in between them. So that's why the order of this matters. It's side, angle, side, because we have one side, the angle in between, and then the other side. So what we call that is two sides and the connecting angle. This is the angle connecting the two sides. If two sides and the connecting angle of one triangle are congruent to two sides and the connecting angle of another triangle, that's also enough to say that they're congruent. So we're going to try to explain what postulate tells us that each of these triangles are congruent. Before we get there, I also want you to jot this down in your notes. There's something in math called the reflexive property. Technically, there's a lot of different reflexive properties. If I want to break it down further, I could say there's a reflexive property of angle congruence. So say I have some angle here. The reflexive property says that this angle has the same measure as itself, which should make sense, right? It's only one angle. Whatever number of degrees it is going to be equal to the number of degrees that it is, right? There's also a reflexive property of line segment congruence. I drew a line segment there. Whatever its length is, it has to be congruent, it has to have the same length as itself. There's also a reflexive property of equality. If I say the number 3, well, it has to be equal to itself, right? For my class, it's totally fine if you just say the reflexive property. I'll know what you mean. But it's good to know there are different reflexive properties. They all have to do with something being related to itself, though. So let's start with example A. And I'm going to try to introduce you as early as possible to a method of proof called a two-column proof. So we're going to make a statement. And every statement we make needs to be backed up with a reason. So the first statement we'll make, it's a good idea to write out all the given information first. So see how we have these two marks here? That means line segment NY is congruent to line segment PY. And there's those tick marks there. I mean, it's just given to us. We don't have to justify it. It's just because the picture says so. And we have another given statement. Because of these two tick marks, I can say that line segment NQ is congruent to line segment PQ. That's given. It's just because the picture says so. Our third statement is actually going to be about this third side of, it's actually a side of both triangles. Line segment YQ is a line segment. It has to have the same length as itself. That's not given in the picture, but we are able to say it because we know about the reflexive property. If you want to be super fancy, you can say this is the reflexive property of line segment congruence. And then now, I could mark this with 3 tick marks if I want to. Do you see how we have 2 triangles and all 3 sides of the first triangle are congruent to each of the 3 sides of the second triangle? So that's enough to say that the triangles are congruent. We're going to say that triangle NQY is congruent to triangle PQY. And that's because of the side congruence postulate. You can just say SSS as your reason. All right, let's try the next one. I'm gonna write statements. So our first one, again, write your given stuff. We know that line segment RQ is congruent to line segment VT because the picture says so. And then these 2 line segments have a length of 4. So again, PQ is congruent to ST because they're both a length of 4. It's given in the picture that they must be congruent. And then line segment, actually no, we wrote down both line segments. We're also given that these 2 angles have a measure of 100 degrees. So we can say that angle Q is congruent to angle T because that's given as well. So notice how we have 2 sides and the included angle of one triangle, and they're congruent to 2 sides and the included angle of another triangle. So we can say that triangle RQP is congruent to triangle VTS, and that is by the side angle side congruence postulate. I want you to try part C on your own. I gave you an outline, but I want you to fill in those blanks that I've covered up and then come back and check your work. Okay. Did you write the 2 given bits of information? We have a pair of congruent line segments and another pair of congruent line segments. And then we said that angle ACB is congruent to angle ECD. Why can we say that? Well, if you remember from 9.1, those are vertical angles, so they have to be congruent. Now we have 2 sides in the included angle of one triangle are congruent to 2 sides in the included angle of another triangle. Make sure you write it in order. A matches with E, B matches with D, and C matches with itself. So, but that's because of the side angle side congruence postulate. All right. There are more postulates. We can also say that 2 triangles are congruent if we know 2 angles in the included, or I keep saying included. Sometimes it's called an included side. Sometimes it's called a connecting side, but it's 2 angles and the side in between them. If they're congruent to 2 angles and the side in between them on another triangle, that's enough to say that the triangles are congruent. You actually don't need the side to be the connecting side, though. So this last one is called a theorem. If 2 angles, like here and here, and a non-connecting side, so this side is not between the 2 angles, if they're congruent to 2 angles and a non-connecting side of another triangle, that's still enough to prove that the 2 triangles are congruent. All right, so now we have 4 postulates or theorems, 4 ways to prove that 2 triangles are congruent. I want you to try these examples on your own. The answer could be anything. It could be side, 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 angle, side, angle, or angle, angle, side. Pause the video, try these 3. Again, you can use my outline and then just fill in those blanks. And come back and check your work. Okay, example 2A. I hope you wrote down the given information. We have 2 angles that must be congruent because they're 90-degree angles, they're right angles. We also have 2 sides that must be congruent because they both have a length of 5. And then we have 2 vertical angles, so they must be congruent. And this side is the connecting side between the 2 angles. So the triangles are congruent not by angle, angle, side, but by angle, side, angle. Part B, we have 2 given pairs of angles that are congruent. Notice that for the red congruent angles, we needed to name them very specifically. I can't just say angle R because there's a lot of different angles at R. But angle PRS is definitely congruent to angle QRS because the picture says so. Angle P is also congruent to angle Q because the picture says so, it's given. And then RS needs to be congruent to itself by the reflexive property of line segment congruence. So this time we have 2 angles and a non-included side that are congruent to 2 angles and a not included side of another triangle. So they are congruent by angle, angle, side. Part C, this is probably the preferred way to do it because we use all of the given information. We have given angles are congruent, it's given that these angles are congruent, and it's given that these sides are congruent. These sides are the connecting sides, so the triangles are congruent by angle, side, angle. Watch how you name the triangles. Make sure you pay attention to the order where P matches with T and S matches with R. I did want to point out, if you notice the vertical angles, you could have proven this a different way. You could have used 1 pair of the given angles. You could have used the vertical angles and then use the side, which in this case is not included, or not the connecting side. And you could have proven it using angle, angle, side. But this is probably the better route because it uses all the given information. That is just about it for lesson 9.4. The summary, though, asks us to name the 5 ways to prove triangles are congruent. And I only gave you 4. I'm hoping that you noticed that SSA or AAA, these don't prove congruence. So you can write it out, think about it, come up with an answer. We'll talk about it in class. But before we go, I want to show you the 5th way. Side-side angle typically does not prove congruence. You can have 2 different triangles that aren't congruent, but still have side-side angle. The only time side-side angle actually works is when that angle is a right angle. And in that case, we call it the hypotenuse leg theorem. Just as a reminder, the hypotenuse is the longest side of a right triangle. And if you know that the hypotenuse of one right triangle is congruent to the hypotenuse of another right triangle, and you also know, that's the hypotenuse, and you also know that one of the legs of one right triangle is congruent to a leg in the other right triangle, we also know that the angle here and here, those are 90-degree angles, so they have to be congruent. Then this is technically angle side side, angle side side, which typically doesn't prove congruence, but when that angle is right, it's enough to prove congruence. When that angle is 90 degrees, we can say the 2 triangles are congruent by the hypotenuse leg theorem. So add this to your notes and then ask a question at the end of the video. If you'd prefer, you can type your summary in as your free response answer, or just make up a math question. And I'll see you all in the next video.